In this video, we are going to talk about extrema on an interval. Extrema means minima or maxima. Okay, if a function has minimum or maximum value in an interval, we call the function has extremum value in that interval. Okay, so extrema also called maxima or minima or maximum or minimum. That's what we call. Okay. So let us look at this graph. The function is defined everywhere, meaning that there is no a point that the function is not defined, right? There is no hole there. You see that? The function is defined everywhere between 1 and 11, closed, because you see the bold, the closed circle on the endpoints, meaning that we use the close or the brackets there, right? So the function is defined everywhere between 1 and 11. So what do you mean by local maxima or local minima? Or in other words, we call relative max or relative minimum, okay? So relative or local max or local min means if a function takes bigger value close to a point in the neighborhood of the point. For example, at 2, you see that the function is minimum, right? And around 2, the function are bigger than that, or the height are bigger than that. So at 2, the height is -2, right? So it is minimum. And around 2, it is bigger than -2, meaning that it is the local mean. You see that? Similarly, at 5, you see that at 5, it takes the highest point in the neighborhood, in the proximity of 5. The height at the 5 is the highest around the points here, right? At 7, it is the lowest around 7. You see that? The height at the 7 is the smallest height that at the points close to 7. So similarly, this is the highest point and that one is the highest point too. But the thing is, at 2 or 5 or 7, you see the combination of decreasing and then increasing and then decreasing and decreasing and then increasing, like that. But at the boundary, you don't see that combination. You have just decreasing and there is nothing on the left side. There is just increasing and there is nothing on the right side. That's the difference, right? Okay, let's talk about the local or relative maximum or minimum. For local maximum or minimum, what we need is the combination of decreasing and increasing, that is the local mean or relative mean. If there is an increasing and decreasing combination, that is the local max. Here it is local mean. Local means only in the surrounding points. You see that? The local means only in the surrounding point. Global means the global max means the highest of all these. And global mean means the lowest of all these. You see that? But for the local or for the global, we also call absolute. Absolute max or absolute mean means global max or global mean. Relative max or relative mean means local max or local mean. Again, local max or local mean is observed only around a point. Okay. Global max or global mean are observed at all the points in that interval. Okay, let us see that. In a Vouvec graph, fx has a local max at x equals to what point has local max? This is one point, right? At x equals to 5 only. Because other points, this one is not local. Why it is not local? Because we don't know what is happening on the right side of 11. The function is terminated at 11, right? We don't know what is at right side of 11. At 5, we know that on the left of 5, the height is smaller than that value, that height. And then in the right of that 5, the heights are shorter than that height at 5. So it is the maximum of the surrounding points of 5, right? So it is in the neighborhood of 5, in the left of 5 and the right of 5, the height at the 5 is the maximum. That's why it is called local maximum. It is the maximum locally. It is the minimum locally. It is the minimum locally. You see that? But at this point and that point, you cannot say locally because we don't know the other side. That is the reason why we cannot say locally. And what is the local? So fx has local max at x equals to 5, and the local max at x equals to 5 Oh, sorry, local, I'm sorry. So fx has local max at x equals to 5 and local mean at x equals to 2, at x equals to 2 and then 7. You see that? Because at 2, the height is minimum in the surrounding points, for the surrounding points. At 7, the height is minimum at the surrounding points, for the surrounding points, right? And what is the local max values? So local max value means at x equals to 5, what is the height? It is 3, right? It is 3. So the value is 3, the local max value at x equals to 5. So it is maximum at x equals to 5, but the value, the maximum value is basically the height. The maximum value is basically 3. You see that? That height is 3. And the local mean values, what are the local mean values? At 2, it has local mean, and the value, local mean value is at 2, it is -2, and at 7, it is 1.5 almost, because at 7 you see that the height is 1.5, right? At 7 it is 1.5. The value or the minimum value are -2 and 1.5. You see that? Okay. Note number 2, for local max or local mean, we do not look at the boundary. We do not check at the boundary. Why is that? Because we will see only the left side or the right side of the boundary only, because we cannot say what is happening on the other side of the boundary. That's why for the local max or local mean, because if you want to check at the local max here, because we don't know what is happening at those points, so you cannot check in the surrounding points. So we don't check at the boundary points or the end points of the interval. Because for local max or local mean, we need, for the local max you need increasing, this is increasing and then decreasing pattern, increasing and then decreasing pattern shape for the local max, and then decreasing and then increasing shape for the local mean. That's what we need for the local max and the local mean. You understand? Okay. So for the global extrema, the global extrema may fall at the boundary. You check at the boundary and the local max and local mean, or may fall at the boundary or inside an interval. Okay, because for the global max or the absolute max or mean, you look at where the height is the lowest and where the height is the highest. Okay, let us see that example. Fx has absolute maximum at x equals to 11, right? Because this is the highest point. At 11, fx has absolute max or the global max, and the absolute value or the maximum value at that point is basically, it looks like 5, right? It is 5. We look at the y value or the height for the value. Okay, fx has absolute minimum. What is the lowest point? This is that, right? So absolute mean may exist at local mean. So x equals to 2 and the minimum value is -2, because the minimum height is -2 there. You see that? Let us look at this example next. So see, the function is defined everywhere in the semi-open interval, meaning that it is like, let's say this is 1, 2, 3, 4, right, and then 5. You can say that function is defined everywhere between 1 and 5, right? See, I use the open interval and then closed interval there. Open to the left because of the open circle and closed to the right. Bracket on the right because of the closed circle. Now, local max. Let's find out local max. Where are the local max there? For the local max, you need like a cap shape, right? Cap shape. And for the local mean, you need the cop shape, okay? See, the function has local max at 4. You see that? At 4, at x equals to 4. Local max at x equals to 4. What is the value? Value means the height, right? So it is, the value is 2. And is there any other local max? No. How about the local mean? The identity has local mean at 2, right? Because it has a minimum value there. Around the point 2, the lowest height is at the 2, right? So minimum at local mean at x equals to 2, and then the height or the minimum value is -1. How about the global max and global mean? Looks like the global mean is at 5, right? X equals to 5, because for the global you look at the boundary as well. And what is the value? Value is -2. right? How about the global max? What is the highest point? It looks like the highest point is right here, right? But at the left boundary, the function is not defined because there is an open circle. And the highest point looks like this, but we don't know what is that value, right? So max, the global max does not exist, because at the left endpoint, the function is not defined. You see that? So we don't know what is the global max, because you cannot say this is the global max because this is just the local max, but there are some values higher than this, there are some heights taller than that too, right? Because there are many of them. But which one is the tallest, we don't know. Because 3 is not the tallest, because 3 is not defined, it is an open circle. But close to 3, maybe 2.9 is the tallest, you cannot say, because 2.99 may be taller than 2.9, right? And then do you think 2.99 is the tallest? No, because 2.999 may be taller. So we cannot figure out which one exactly, which one is that. That's why we say it does not exist. You understand? Okay.